So this is already a pretty good setup. To make this more interesting, we might want to have this animation frame parameter actually trigger our geometry to change to create kind of more interesting animation. So here we can actually put in this animation frame as the random seed. So as the camera rotates around, we create new pieces of geometry. Or we can actually have this animation frame trigger for one specific design how many boxes are instantiated. And that's what I did in my example video, where I had this animation frame control how many boxes are visible. We can do this by creating a sublist component. So if you remember, out of this Python script, we're actually just outputting a bunch of points, and those points are used as the base for the boxes. So to do that, we can actually insert one of these subset nodes to take in this list of points, but only use a certain portion of them to create the boxes. Okay, and here subset takes a domain which specifies the range of indices that you want from the list. We can create a domain construct node. For the A, we're going to keep the default at 0, so it's going to start with the first item. And here we're going to pass in the frame. So it's going to only output the boxes from the first box to whatever specified in the frame, so it's going to have the effect of building up the geometry over time. Finally, the subset we're going to pass into our move and into our box. So now as we move through our animation, you can see that the boxes are building up. And one interesting thing is that you can actually see the sequence that the recursion script uses in creating these boxes. You can see that one branch will complete, and then another branch will start. And this kind of visualization can not only be pretty cool, but it can also help you see what's going on with your script and how it's working. Okay, so this is already a pretty good setup, and the easiest way if you want to output this as an animation is to actually use the animation feature within Grasshopper. So if you right click on any slider, there's this animate function which will basically allow you to output screenshots of your Rhino viewport while increasing the value of the slider. I'll create a new folder on the desktop, call it animation viewport. And what Grasshopper is going to do is it's basically going to step through the number of frames I specify. So here I'm telling it make 100 frames. It's going to step through 100 values of the slider, and each time output a frame from as a screenshot from my viewport. And here I can set the frame dimension and also how it names the frames. So if I click OK, it's basically going to run through that slider one frame at a time, and each time output a new image into the folder. Okay, so you can see those images here, and if I want to make an animation now, I can just dump these into After Effects or another application like that. So that's already pretty nice, but say for instance that instead of outputting screenshots, I actually wanted to render each frame to do like a true kind of rendered animation. And by default, you can't do this within Grasshopper because Grasshopper doesn't have any control over the renderer, since that's not related to the geometry, and it's actually a function within Rhino itself. But one of the advantages of scripting is that we could actually have control not only over the geometry within Grasshopper, but we can actually control geometry within Rhino and control functions within Rhino like rendering. So to make this work, the first thing we need to do is actually bake that geometry into Rhino. If we try to render this scene now, none of the objects that are in Grasshopper will actually render. So to have them show up in the rendering, we have to bake them into Rhino. Okay, so to do the rendering, I'm going to create a new Python node. And the first thing I'll do before anything else is I'm going to create one of these inputs, call it active, and then into that I'm going to plug in a Boolean toggle and start it off as false. This is a common way to start doing Python scripts, is creating this input which triggers whether the script is going to be executed or not. And this is really useful to do when you're scripting things that might take a long time. So in our case, rendering takes a long time, so you don't want to trigger every time you change anything in your Grasshopper window. So we're going to set this to false, and then when we start doing our script, we're going to wrap all the functionality of the script in this conditional that tests whether active is true. Okay, so everything we do in the script is going to be done in here, and that will have the effect that when this is set to false, nothing in the script will run. Okay, the next thing we need to do is create an input for our geometry. So here I'm going to create an input called geo, and we're going to plug our box geometry into there. Okay, so now I can start writing the code to bake my geometry into Rhino. I need to import a few libraries to make this happen. So we're going to import our usual Rhino script syntax as rs. I'm going to also import the script context library as sc. So this will control, again, which document the script is referring to. And then I'm going to import the general Rhino library. Okay, so now within this conditional, so if this is true, I'm going to write the functions to bake the geometry. I'm going to start with a loop statement to loop through all of the geometry that I'm putting into this input. So I'm going to write for I in range length geo. So again, this will calculate the length of the input and then create a range of integers and then step through that range with I, colon. And inside the loop, the first thing I'm going to do is reference an element within the geo list using the square bracket. So here I'm going to assign geo ID variable as whichever piece of that array we're currently on. Next, I'm going to use script context to establish the Grasshopper document as our current context. And here I'm going to reference the actual surface object from this geo input. So like before, we're using points, we're using coerce 3D point. Now we're going to use a more general coercion function. So we're going to type in rs and coerce, and we're going to use the general coerce Rhino object function. And this will bring in any generic object from Grasshopper into our script. And I'm going to pass in our GeoID reference. This has a similar effect to this general geometry input, which can contain any geometry that we pass in. And this is really useful, but the catch is that we need to then be specific about which aspects of that geometry we're going to be referencing. So with points, when we coerce to 3D point, it already comes in as a point. In this case, a generic Rhino object has several different pieces or parameters, and we need to pull out the right ones. So to do that, we're going to create a variable for the geometry of the object, and here we're going to reference our doc object variable and then dot geometry. So just to see what this looks like, if we print doc object and we set this to true, and then the last thing we have to do is actually change the type of input this is. So before we're always inputting single values. In this case, we're going to input a list of boxes. There's going to be multiple pieces of geometry. And in order for Python to understand that this is a list, we have to right-click on the input and change this to list access. So by default, it will look at all the boxes as one object, but we actually wanted to look at the objects as part of a list. Okay, so we're going to change this to list access. Okay, so if we hit test, and then we have to set this to true. You can see that when we print the doc object itself, there's a variety of parameters that are contained within that reference. There's geometry, it's a surface, there's also attributes. There's a lot of different parts to it, and what we need to bake it is we need a separate reference to its geometry and to its attributes. So here we're creating a geometry and getting the geometry from the object. And then we're also going to create an attributes variable and do the same thing to get the attributes from the object. So now if we print the geometry and print the attributes, you can see that's pulled out each of those pieces from the object. Alright, so once we have the geometry and we have the attributes, we need to switch the context of the script to actually reference the Rhino context, because we're going to perform functions not in Grasshopper but within Rhino itself. So to do that, we type in sc.doc, And here we set it to rhino.rhinodoc.activedoc. Okay, so this will reference the active document running within Rhino, and for that you need this Rhino library, so that's why we imported it above. Okay, so once we have that reference to that document, we're going to bake our geometry into Rhino. And to do that, we use script context again. So we set sc.doc.objects.add. So this function will add any object we've generated here into that Rhino document. So it's in a way baking that geometry. And as an input, we'll pass in the geometry and its attributes. So if we hit OK now, you can see that's actually baked our first box into Rhino, and now it's a physical object in the window, and if we render, it'll actually render that geometry. And if we increase our frame count, you can see that it's automatically generating that geometry. So there's two problems right now. The first is that we don't have any control right now of the layer or the material that's baking this geometry with. And the second problem is, as you can see, they're kind of piling on top of each other. Every time this runs, it creates a new piece of geometry, so it keeps baking every time. So we need this more control over how the geometry is getting baked, and also a way to delete the geometry at the end of each frame. So to have control over how objects are baked, you actually have to first get a reference to that object and then make changes. So instead of sort of specifying all the options right away, you first bake that geometry and then you can change different aspects about it. And this can relate to things like changing the color of the object, the name of the object, and the materials. But in this case, we're just going to use it to move the objects to a new layer. And we're actually going to specify the material properties that we want by layer. So I'm going to create a new layer here called layer 01. I'm going to change the material to be a different color. And now any object on that layer will be that color. And now we just have to tell Python, once the objects are baked, to move them to our new layer. So to do that, we need a reference to the object that was created. And this add function, by default, will create that object, but also return a reference to it in Rhino. So to capture that reference, we can just make a variable called rhinoref and set it equal to that function. Now rhinoref will have a link to that geometry in Rhino. And now we can use different functions within Rhino script syntax to change different properties for that object. So in this case, we're going to use rs.objectLayer. This takes two inputs, basically the geometry reference. So here's, we pass in our rhinoref, and then the name of the layer that we want it to be on. So we could just type in the layer name, but I'm going to actually input it as an input into our script. So I'm going to create a variable called layer, and then hit OK. And then here I'm going to set this to false, so it stops creating these boxes. And in my script, I'm going to create a new input, call it layer, and then create a panel with the name of the layer that I want to bake to. You can see how you can start to build up the script to actually make it more user-friendly. So in the future, if you want to bake to another layer or a series of layers, you can always just change this input. Okay, so now if I hit true, you can see that this has actually baked that geometry into our new layer 1. And now if we render, all that geometry will be the colors that we set through those by layer options.